All right, guys, we're back, and we need to now look at part 5, which is asking us to determine the inverse, and the inverse is denoted like this, as was explained and discussed last week. So they're asking us to find the inverse of that function. So the first thing I'm going to do is I'm going to write what the original function is. F of x is equal to 3x minus 4 divided by x plus 6. That's the original function. So again, if you recall from last week's session, our first step is to let y equals 3x minus 4 divided by x plus 6. Now remember, we're attempting to find the inverse of this function. So our first step is to let y equal the function itself. Then our third step is to interchange x and y. And that simply means just to switch the positions of x and y. So wherever x is, we're going to put y. And wherever y is, we're going to put x. So we have y here. So we're going to put x there, and wherever you say x, we're going to put y. So we're interchanging x and y again. Wherever you see y, we put x. And wherever you see x, we're going to put y. So looking at this, it's going to become x equals 3y minus 4 over y plus 6. So we simply just change the positions of x and y. And I said before, this is just a rule that we follow to find the inverse. Now, all we need to do afterwards now is to solve for y, which means to make y the subject. So we want to know what y is equal to. So I'm just going to stress this step here because I'm going to make a change to it. All right. Remember, all we're doing now is solving for y. So what we're going to be doing here is very, very simple. The denominator is y plus 6, and I'm just going to put that in brackets because what I'm going to be doing now is cross multiplying by the denominator. So what I'm going to have is x times the denominator here. So we're cross multiplying by the denominator. It's as simple as that. 3y minus 4. And then we're going to do simple expansion there. So we're going to expand this. So x times y is xy, and x times positive 6 is positive 6x. I'm going to write back what is on the right hand side. Now what we're going to do now is put all the terms with y on one side and everybody else on the other side. So all the terms that we have with y, xy is already on this side, so I'm going to move this positive 3y and put it over so it will become negative. And then I'm going to take this positive 6x and carry it over, it's going to become negative 6x. So we have x, y here. I'm going to move the positive 3y, it's going to become negative 3y. And then I had positive 6x here. I'm going to carry it over, it's going to become negative 6x, and put back the minus 4. So that's what I'm having now. Now, the trick now, in order to get just one y, because we have two instances or two terms with y in it. Now remember, we want to make y the subject, which means we want to see what y is equal to. So what we're going to do very simply is to factorize this, take out what is common, and what is common in there is y. So we're going to factorize here. So y is common, so we have x minus 3 in the bracket, and minus 6x minus 4. And then now, seeing that this means y times that, to make y the subject, we're simply going to divide the minus 6x minus 4 by x minus 3. And seeing that we've now found what y is equal to, which means we've solved for y, then we clearly will know what the inverse is, because whatever y is equal to, that essentially is the inverse. So therefore, the inverse of f of x, remember, the inverse of f of x is different from f of x. F of x was the original function. We're asked to find the inverse of f of x, which is denoted like this. And this is equal to what we found for y, which is minus 6x minus 4 divided by x minus 3. And that would be the solution to part 5, where we found the inverse of the function. And again, a few more steps, obviously, than when we're looking at finding the inverse of simple functions, and we have a few more steps simply because the function f of x is in fractional form, or it's a fractional function, and that is why we incorporate so many steps here. All right. So again, we let y equal a function. We're just following some compulsory steps. Let y equal a function, which is what f of x is equal to. We interchange x and y, so wherever y is, we put x, and wherever x is, we put y. We had 2 instances of x, so that means we have 2 instances now of y, and where y was, we put x. And then afterwards, we solve for y, which involves some interesting steps. The first thing is you write this back and put the denominator in bracket. It must be in bracket, because if you cross multiply without the bracket, then you're only going to be multiplying the y by the x. So we have to have it in bracket. Cross multiply, we have this, and of course the right hand side, and then we do expansion here. X times y is xy, x times positive 6 is 6x. And then all we do from this line here to get to that one is carry all the terms with y on one side and everybody else on the other side. So we move the 3y, the positive 3y becomes negative 3y, became negative 3y, and positive 6x we carried over, it became negative 6x. And from this step, we factorize out, or we factored out the y. We use simple factorization and factored out the y to get this. Right hand side is there, and then to get y, we just simply divided the right hand side by x minus 3. And whatever we got for y, that is what the inverse is equal to. Alright guys, that takes care of example 1. I hope you found this video insightful, and I'll see you guys on the next video.